All right, good morning, everybody. Today is Monday, October 24th, and we are going to begin chapter 4 of our textbook on Excel. And today we're going to start talking about logical statements, which is sort of the first level of programming using the Excel spreadsheet. But before I do that, I wanted to let you know that the spring 2025 schedule has been posted. So that means that you can start making decisions about your spring semester in terms of your coursework. So maybe it's worth it to just take a minute and take a look at that. But if you go to, let's see, I want to share my screen so I can show this to you. I know it comes through in this classroom, but I'm not sure it comes through in on the recording. So if you come over here to nwc.edu and then academics, then class schedule and syllabi, you will have the link to go to the class schedule and syllabi. And so you can take a look here and you'll see up in the upper left that we are at the spring 2025 semester. So for example, if you wanted to consider which math course you're going to take, you could just choose math as a subject and look at the math courses that are available. And you can see that we're offering Calc 1, Calc 2, and differential equations. So Calc 3 is not offered this semester. However, it may be offered through another Wyoming community college. And the best way to find out if that is the case is to come up here and go to the URL is called Y-Class. I have it as a saved link here, but go wyclass.org, and Y-Class will show you all the courses that are available at Wyoming community colleges in the spring. So if you go to spring 2025 and you take a look at the math courses, once again, mathematics, there's so much developmental math that they have their own tabs, so they show up twice. But if you take a look here and you go all the way down to the second page, we have, we do have elementary linear algebra. That may be a course that if you're an electrical engineer, you wish to take. So that's something to keep in mind. And we do not have Calc 3, just Calc 2. But if you're an electrical engineer or computer scientist, you may consider taking elementary linear algebra, which, trust me, is not regular algebra. But it's a very good course, and it's very good for a lot of different things, but for working systems of equations and doing a lot of logic, a lot of structures that are more difficult to do with other means or by hand. So, and it will be required for some of you. But anyway, so the other thing I would like to remind you of is November 5th, Tuesday, is advising day. And what that means is it's an opportunity for you to meet with your advisor and get your schedule set up for the spring, and also just a chance to talk about your academic goals. So if you are my advisee, the easiest way for you to set an appointment with me is to use the link to my Calendly program, and that's available on all my different class pages. But here in ES 1060, you can use right here where it says calendly.com /Northrop, and you can set up a 30-minute meeting with me. There are two things that I would like to say. One is it will automatically assign us a Zoom link, but if you want to meet with me face-to-face, just send me an email and say I'll be in your office, and I'll make sure that I'm there and we can meet face-to-face unless I have a scheduling conflict. And the other is you don't have to wait till November 5th. Now that the schedule is up, we can meet anytime that you want. So use that Calendly link and meet with me anytime you want. If you have a different advisor, make sure that you visit with them so that you are ready to go in terms of whatever their schedule looks like and however they schedule people. I know there's still a lot of advisors who put sign up sheets on their doors, so you may have to go to their office and look and sign up on their door, but there's a lot of options that are available to you. The other thing is, just so that you know, if you take a look at the engineering science courses that are going to be offered in the spring, we have a bunch of them, and it's kind of actually sort of a maybe not scary amount, but it's a little overwhelming. But there's a couple of points that I would like to make. First of all, engineering surveying. If you are a geological engineer, a civil engineer, or an architectural engineer, you will have to take that course. You'll take engineering surveying. We do the labs with the drafting students who have a different lecture, but we'll meet Tuesday afternoons from 3 to 5 essentially. And that is a requirement for civil engineers and architectural engineers are our two main draws for that. I'm offering statics again. I'm not sure. We'll just see who signs up for that. I also have thermodynamics and mechanics of materials, which are fully online, and then electric circuit analysis. Circuits is a weird requirement, but if you're in computer engineering or electrical engineering, you will be required to take circuits. If you're going to school at Montana Tech, you'll be required to take circuits. And the surprising one is if you are a mechanical engineer and you're going to University of Wyoming, you also need to take that. And you need to take it in addition to a whole bunch of other courses before you're allowed to take any mechanical engineering courses at UW. Mechanical engineering at other colleges, that is not necessarily the case. But if you are an electrical engineer or a mechanical engineer at UW, please make sure that you put that on your roster. And the other thing, as you can see, is we're going to do the lecture as a recorded asynchronous lecture, but the lab will meet face-to-face. So meet face-to-face on Wednesday afternoons. So there's a lot of stuff going on with advising, and I'm sure that you will have good advising, but great advising can really make a difference. So make sure that you visit with your advisor and be as clear as you possibly can be about your academic goals so that we can get you squared away. All right, so having said that, let's talk a little bit about what we're doing in this course in ES 1060. And specifically, let's talk about loops when we are working in Excel. Now, people in this class, you guys have a little advantage because we worked with if-then loops in MATLAB. And so you know the idea of this. But a logic structure, these are sometimes referred to as Boolean algebra, after, I suppose, the person who came up with this whole idea. But Boolean logic or Boolean algebra just is, if one thing happens, you do one thing, and if another thing happens, you do another thing. But that's a logic structure. But a Boolean logic talks about comparison operators. So the one comparison operator that we have worked with for basically our entire academic careers is equal. When you have a left-hand side of the equation that's equal to a right-hand side of the equation. But we also have less than or equal to, gotta draw that correctly, greater than or equal to, and also, of course, not equal to. So each of those functions, each one of those comparison operators is available to you in Excel. And when you use them in Excel, it can be very handy, especially if you have just stacks and stacks of things and you want to, for example, sort things out. So one example of this where Excel could come, I mean, there's a zillion examples, but as an example, let's just say that you were working as, and I'm thinking about the election coming up on November 5th. So we won't talk about anybody's politics, but let's talk about the mechanics of running an election. So if you are running for a particular seat, or if you're an election official and you need to sort people into their voting districts, you can take like streets, and you can sort them out by saying, if this person lives on 7th Street in Powell, they go into this bin. If they do not live on 7th Street in Powell, they go into this other bin, okay? So you can do sorting things like that. Less than, or equal to are more numeric. You can use the not equal to, equal and not equal can be numeric or non-numeric. The less than, greater than, less than or equal to, greater than or equal to are generally speaking numeric. But so, for example, if you are trying to determine, say you are doing a school dance and there's going to be a different room for people who are 18 years old and people who are younger than 18 years old. Well, you could say if they are greater than or equal to 18, they have these privileges. Otherwise, let's be an or, they have a different set of privileges. So this would be a greater than or equal to because you want to include people who are 18. You could also say if they're older than 17, but then if you're working on a birth date, you might have somebody who's 17.625 years old, and then you would want to sort them differently. So for example, once again, in the United States, 18 is a magic number. Oh, let's just talk about voting instead of that. So can a person vote? If they're greater than or equal to 18 years of age, yes, they can vote. So that's an easy one to think about. So what these comparison operators can do for you in Excel is to sort things, or you can put things into different bins. And if you're setting up, if you're doing statistical functions like histograms, you can also use these, although Excel also has a bunch of statistical functions in that would make it much easier for you than having to go through that process. All right, but so that the logical expressions and the Boolean operators are just extraordinarily important, and they're humongous time savers for you as an operator of Excel. We also have the not function reverses, so it's sort of along the same ideas, but they show you the structure of how you look. And this is the other reason I want to point out, when you're using Excel, this is why I can only accept as your homework, and later on any quizzes or an exam that we may have, I can only accept an Excel file, not a flat file of any sort like a PDF, because I need to see what that formula looks like. And it may be, it's not really surprising. In the past, I've had students who are just really hesitant to get into these features in Excel. So they'll actually do it off Excel and then put the right answer into a cell in Excel, which it still works that way. But the whole purpose of what we're trying to teach you with Excel right now is this automated function to make your life easier. So I want to make sure that you're making it easier. So here's the way you would just enter this into a cell. And it just says if whatever the content of C1 is greater than 100, then we have a comparator. We have the value of 50 will be placed in cell B5, which is where this formula is. So you put this cell in B5, and then it says if it's greater than 100, it becomes 50. Otherwise, which is the comma, you take the value if it doesn't. So if it did not exceed 100, so this is greater than 100, right? So that means if that cell was 100, it would not meet that criteria, right? It has to be 100 and a little bit incrementally larger. So then it would be C1 divided by 2. So let's just see what that looks like in Excel. So I'm going to pull up a little Excel spreadsheet. And there's one other thing I wish to show you. All right. Let me stop sharing and let me share something else. Here we go. All right. So there's my Excel spreadsheet. So let's do this. I'm going to scoot this over here. I'm just showing you a little wee bit of that because I want to be able to see what's going on with my screen as well. So I'm going to put this in cell B5. So here's column B, here's row 5. And so always when you have a formula in Excel, you start off with an equal sign. So if, and I want to be clear also, capitals don't really matter in Excel. It can be lowercase or uppercase. But we have if, so whatever's the content of C1 is greater than 100, then we're going to return a value of 50 into this cell. Otherwise, we're going to take that value in C1 and divide it by 2 and return it in this cell. Now, this is going to tell me that there's nothing going on because whatever's in that cell C1 is just nothing right now. But let's put over here, what if it's 50? Well, it's not greater than 100. So that means it's going to be half of what's in C1. What if it is exactly 100? It returns 50. And what if it's, say, greater than 100, 200? It still returns 50. So you can probably also see why I need to see your formulas to make sure that you've constructed that properly, because you can just type 50 into that cell and it's going to look okay, but it's not doing what it's supposed to do. You haven't automated your spreadsheet at all. Okay. The next one talks about instead of returning numbers, we're going to return these strings. So if it's greater than 100, it's going to print out too big, or it's going to display too big. I should say. Otherwise, it's going to return a value of okay. So let's just take a look at how that works. All right. So here, what we're going to do is come back to the cell, and you can see in the formula line, we have our same formula. We don't even have to retype this, but we can just say, put in quotes, because that's how we indicate that there's a too big, my Montana accent is coming out again. There we go. Otherwise, we're going to return the value, the phrase okay. All right. So let's see. So there we go. It's 200. It's too big. What if it's less than? It's 50. It returns the value okay. What if it's 100? There's my break-even point. What if it's 100.1? There you go. So that's how you automate a spreadsheet, and it's really, really helpful. Later on, we'll learn how to pull different values out. Like we can take a look and say, if it looks like this, put it over here, create another chart, and so forth. Something that this is really useful for, well, I won't go into that right now. We'll just kind of continue through this. So this is just how we do an if function. You can also nest if functions. So this is how you would do like an if then else statement using Excel. So you can put an if inside of the if. The most important part in terms of the syntax of Excel is just like with any programming language, right here, you want to make sure that you always open and close parentheses on the correct string on the correct logical operator or function. So you always have to have, for every open parenthesis, you have to have a closed parentheses, and they have to nest properly. So, and this is like perennial. I've never seen a programming language that doesn't use this. So it's really important. The easiest way for me to do this, to make sure I always get my open and closed parentheses correctly, is to start in the middle, start at the very core function, the most primary function that there is. So if I were to write this string, I would start here with the if A3 is less than 100, print out water, otherwise print out steam. Okay. And then I would go to the next one. If A3 is less than 0, then print out live ice, otherwise do this, is what it's really saying. So it's an if then or an if else statement, but always start in the inside part. Here, you notice there's a open parentheses and we close over here. So there's two different statements. So here's the first one, and then here's the condition, and then here's the third one. So, but if you just start at the very inside and nest your way out, it'll go really, really well. All right, so that's sort of the deal. It's extremely powerful, and it is not, I would consider, difficult, but it's extremely, there is a syntax that you have to follow. Something like this, just for your information. I do this all the time. I mean, not exact, mine looks a little bit different, a little bit sloppier, but basically, if you take a look at this, every time, even though we use the Moodle gradebook, I always pull your grades over into Excel. Because I want to double and triple check, because I don't want to give anybody the wrong final grade in a class. So I always use this. And I also, for example, in one of my classes in dynamics this semester, I ended up doing a curve on the grade. And it was because well, it was two things. One is I curved it because the average was lower than I had expected. And the other thing is when I looked at the grades, although 5 is not a good statistical sample, what I realized was there was just, it was, how would I put this? It was not, the bell curve did not peak at the right spot for me. So in other words, I never, ever, as I've told you before, I never curve down. If you make a 90% on an exam, you're guaranteed an A no matter what. But I reserve the right to give you a better grade than your raw score. In this case, my raw score and the distribution of the scores indicated to me that the exam was too hard. None of the problems were particularly out of the realm of what were good problems. There were just too many hard problems for a 2-hour exam. And there was too much in-depth stuff. Possibly there was some of the in-depth stuff that I did not cover thoroughly enough. So for all those reasons, I curved the exam. But I could, if I had these exam numbers, I also curved the exams using Excel. So let's look, for example, student. I'm not going to put anybody's real grade or anybody's name down here, but we have students, because I'm really creative, A, B, C, and D. Okay. And let's say their exam score was 70, 60, 55, and 78. Okay. So the first thing is, if I look at a curve, sometimes you can curve top grade to be a 90. So I could do a plus 12 curve. And what that would do is equals B9 plus 12. And that would give me that score. Then I can copy that number. But if I do that, I really don't, I don't get a great distribution. This one's actually better than the one I did before. But there's a bunch of different ways that you can curve. One of them is the square root times 10. And what that time tends to do is to pull up the bottom score. So you take this cell and you find the square root of it. So in other words, I take the square root of 82. That cell is C1 or C9. And then I multiply it by 10. And what that tends to do is to pull up the bottom quite a bit. So let's see. So if I do that, in this case, I would have 2 A's and 2 B's, which would be a little bit high. If I were to do the just add 12 points, it would be, I would have an A, a B, a C, and a D. This is kind of a flat curve, but when you only have 4 or 5 data points, you really can't make decisions. But so I can look at both of those kind of curves, and there are other curves as well, and then decide which one gives me a distribution that seems to be more in keeping with what I would expect the students to do. The good news about a square root times 10 curve is fewer people fail, because if you think about it, to get a D, which is a 60, all you really need for a raw score is a 36. So I tend to always look at the square root times 10 curve because especially if the test is too difficult, it's a good curve to help out everybody, I guess, or to give a good distribution of scores. Anyway, but like I said, I'll never curve down. You make a 90, you get an A, that's it, period. So, but I reserve the right to give you a better score than your raw score would, a better grade than your raw score would suggest. All right. So here are some other functions. When we take a look, we have a function here that we haven't introduced yet, which is mod. Okay, and so what does a mod score mean? So one thing that you can do, if you're interested in that, is to type in equal mod and see what it will tell you. Over here on the right, it shows you that it returns the remainder after a number is divided by a divisor. Okay, so in other words, if you divide, let's just do this. So you have your number like, let's see. Then you could go, let's see, what's one over here, B15. And then we want the divisor, yeah, comma. Let's say we divide things by 4. Okay, so if we put in 10 here, the remainder should be 2. You see that? And actually, I should have put this one up here. I don't like that one. It's down there like that. Let's do this. Let's do 14. So if we put in a 10, 10 divided by 4 is 8 with a remainder of 2. If I put in 12, my remainder should be 0. okay, and so forth. And so those are other things. Sometimes you can truncate, you can just get you can get the whole number apart, you can round it, whatever. But there's a lot of really interesting functions in Excel that will help you a lot when you're doing things. And if you ever have any questions, here's a search item right here. So like if you want to search on the mod function, you can just tell it what it will tell you how to work with it. Just give you a little drop down menu, a little pop-up menu, I guess would be the best thing to call it. And it will do the mod function for you. And you can see it's already put it into that cell. All right, so the point I'm getting at today is Excel is really powerful, and there's a whole lot of things you can do with it besides add up columns of numbers, although adding up columns of numbers is also a very powerful thing. So let me ask you a question, or I guess I should just say this. Some people, so I'm just going to assume that maybe you've not been worked with natural logarithms or natural bases. So what is a logarithm, first of all? A logarithm is an exponent. It's really that simple. So if you have 10 squared equals 100, that's exactly the same as writing the log of 100 to the base 10, which is assumed, is 2. These two are equivalent statements. Okay. We have a base 10 numeric system because we have 10 digits. We have 0 through 9, and so we basically use a base 10 all the time. So if you use the word logarithm, it assumes that it is a base 10. And so other bases, you can use other bases as well. But one base that we use often is called the natural base. And on your calculator, it is referred to as E. And E is actually it's a number that results from an infinite series, but the value is 2.7 with a whole bunch of decimal places afterward. And then we can use a natural base and a natural logarithm. So ln just means a log to the base E. Those are equivalent statements as well. I should put some argument here to be exact. Okay, so what is the big deal about a natural logarithm or the natural base? Well, it's something that just keeps coming up in the real world. So I love the AI generated stuff. I haven't turned this off. Mathematical constants is based on natural logarithm and an exponential function. It's an irrational number, meaning it has an infinite number of decimal places. So there's an approximation of it. It's used to model continuous growth and decay. What that's really telling you is it's just something that happens in nature. It's kind of like the number pi. Pi is a transcendental, or it's also an irrational number. It's just something that comes up over and over again because it turns out that pi is the ratio of the circumference of a circle to the diameter of a circle. So E is the same kind of a thing. It comes up over and over again. But in Excel, you have a lot of functions where you can use both the, I should share that screen before I close it down a little bit here. You have a lot of functions where using a natural logarithm is quite easy and quite helpful if you're doing these different kinds of growth or decay functions, especially like in biology, we encounter a lot of those. Okay, so Excel also has all of those things built into it. So that's what they're talking about in this next course. There we go. So also, when we start looking at these in this chapter, we find that we're talking a little bit about statistical functions. Now, we're talking about random numbers, we're getting things in between, and we're really kind of leading into this idea of different types of math. But Excel also has extraordinary statistical functions built into it. There is a program that is usually used for especially humongous data sets when you're doing statistical analysis called SPSS. And SPSS has literally been around since before I was born, and it is the clunkiest program in the entire world. They have tried to make it better, but it's still very clunky. Excel is not clunky. And Excel is not as advanced as SPSS, but it will do, once again, getting back to Dr. Glatzer's expression that Excel is not the best tool for anything, but it's the second best tool for everything. It is definitely the second best tool for statistics, in my opinion, SPSS being the first. But there were a lot of times where when I was doing some work with some big data sets and doing some statistical analysis a couple of years ago, and I used SPSS, but I first put my data into Excel and looked at how it behaved in Excel because I had more access to sort of my data as a raw data set in Excel. And I could look at it and see where I was getting skewed instead of just being told you're skewed here. I could see it myself, you know, so I find it to be very useful. And then of course, the other part is, I've never seen a desktop in which SPSS is a part of the basic package. SPSS is an expensive program, and you can get Excel using everything else. When we're doing our homework, it's the last thing I want to talk about today. These are the formulas for compounding interest. And these will be so important to you in your entire life. So every time that you buy a house or a car or a jet ski on credit, or you're paying off a credit card, these formulas will govern how happy your life will be, kind of using a little bit of exaggeration, but really not too much. So if you understand compound interest and you don't let it happen to you, except when you absolutely have to, you will have more spending power at the end of every month, regardless of your salary and your other commitments. But so this is basically saying, so this is also when they annually compound, that means that they charge interest to you at the end of the year. And then the next year you're charged on not only the principal, which is how much you originally borrowed, but the interest that has accumulated then that you have not paid off. This is exactly the way amortization schedules work, which amortization schedules are used frequently for housing costs. And when you figure up your house payment and you figure out how much of that goes to interest, I'll put up a spreadsheet on our Moodle page so that you can look at that. But it's a little bit horrifying how much money you pay in interest. For example, if you bought a house, you pay about 2.5 times the value of a house at a typical interest rate. So if you were to buy a house that the sticker price on it was $300,000, you would actually end up paying about $750,000 over the 40-year course of a mortgage. Now, most people have to buy houses on a mortgage because most of us do not have $300,000 to just give to somebody to buy a house. So it's a valid use of compound. It's a valid reason to accept compound interest into your life. However, you can do some things. For example, if you pay off extra, like say if your house payment is $1,800 a month and you pay $2,000 a month, the $200 extra a month you have goes directly to interest. And so because it compounds, you're not only paying less, you're paying off interest at, they call it the backside of the loan, which means it just sucks it up off of the bottom. And so if you pay $200 extra a month on an $1,800 mortgage, you may end up paying off your house in 27 years rather than 40 years, which is nice. And you also end up paying that much less in overall cost. So there's some really good ideas about that. But amortization tables are awfully, like I said, they influence your life in a lot of ways. And my basic advice would be, do not ever carry a debt on a credit card unless something truly extraordinary happened, because that will eat you alive in the shortest amount of time possible. Anyway, enough of that. So 4.8, the Reynolds number, this is a dimensionless constant that you guys will learn about in fluid dynamics, but it's extraordinarily important when you have fluid such as water moving through any sort of a conduit at any sort of a velocity. There are three different ways. Basically, they're classifications, but if the water is laminar, that means that it's nice and fluid and smooth. Laminar is predictable. Turbulent is a chaotic behavior, and it's really unpredictable. We really don't have good math to govern turbulent flow. Turbulent flow is a mystery in a lot of ways. And it's a mystery not because we don't have enough math, it's because the behavior itself becomes dependent on very small changes in a lot of different things. And so all we can really do is model or just come up with something that looks like that flow and then use it as a basis for determining it. But turbulent flow is really tough on a lot of different equipment, and it's tough to understand what's going to happen. And then a transitional flow is equally as unpredictable, but less desirable. So using a Reynolds number is something that we do constantly all the time. Whenever you're doing flow behavior, you always have to predict whether it's going to stay laminar or turbulent. And so a Reynolds number is something that you will see very often, especially if you are a civil engineer working in water resources or a petroleum engineer or a chemical engineer. It will be your best friend forever. So, and there's a lot of, by the way, there's a lot of those, they're called dimensionless constants. There's a bazillion dimensionless constants that define what different behaviors of different physical quantities are going on. Maybe you've seen that if you've taken chemistry, the ideal gas equation. And then we have some stuff about target practice, and then we'll get into chapter 5, graphing data, which is another really, really powerful tool. But anyway, so chapter 4, in my opinion, chapters 1 through 3, we really covered the basics of Excel. And if you've done Excel before, if you've worked with Excel, a lot of it may have seemed familiar to you. Now we're getting into some really cool stuff where it's going to be able to help you. And I really like this textbook for the fact, I like this textbook for a lot of reasons. It's very logical, but because it's aimed at engineers in spreadsheets, using spreadsheets, it brings in a lot of engineering problems so that you can see how that might affect you in your career later on. And you may even build something that would help you. I put together many, many years ago, I put together an amortization sheet in Excel for a real estate company that I was doing a little bit of consulting work for. And they used it forever. They used it forever. And then I actually sold it to some other companies as well. So doing something quite simple like that, I made a lot of money, which was really fun because it didn't take very long. And then I used it myself a lot when I was buying and selling things. So so it can be very, 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 very helpful. Anyway, so that is that's kind of the essence of what we're doing today. I will be in the lab to help you this afternoon. So please come if you have any questions. And if you're not able to attend today, I know one of the classmates is sick. So if you're not able to come today, I still am having trouble getting on Zoom in that room. So I'll bring my laptop and I'll be available. But basically, you can ask me questions anytime or set up a Calendly appointment with me as well if you're not able to come. Otherwise, I'll see you in lab this afternoon. So there we go. Stop recording.